Hello viewers, welcome to Senior College Mathematics. Topic of discussion is probability. Lesson 10, Selected Problems, Part 2. Example 40. A random sample of 60 candidates who sat for Part 1 and 2 of the JAMB examination in a certain year is taken. The table below shows the number of candidates who passed or failed each part of the examination. You have part 1, those that passed and failed. You have part 2, same thing, and the respective totals. Roman figure 1, copy and complete the table. Roman figure 2, if a candidate is chosen at random from the sample, use the table to find the probability that the candidate, a part of Roman figure 2, passed part 2, B part passed parts 1 and 2, C part passed part 2 but failed part 1. Roman figure 3. If a candidate is chosen at random from the subgroup of those who failed paper 1, find the probability that the candidate passed part 2. Let's take the solution to this selected problem. Solution. To get this part, we can use these two values, that is this row, through subtraction. The total is 35. Those that failed, 20. Those that passed would be 35 minus 20, and that is 15. To get this, you can use this total and 24. Through subtraction, you have 36. So you know this. To get this total here, you can subtract 60 and 35. You have 25. 20 and 36. If you subtract 36 and 20, you have 16. You can get this in two ways. You can subtract 25 and 16, or 24 and 15. You have 9. Roman figure 2, part A. Let E1 be the event that a candidate choosing at random passed paper 2. This is paper 2. Then those that pass is the entire row. The total is 25. So they are 25. Total number of candidates, they are 60. So therefore, probability event E1, those that passed paper 2, is equal to number of students in event E1 over total students or candidates. That is 25 over 60, and it reduces to 5 over 12. Roman figure 2, part B. Let E2 be the event that a candidate chosen at random passed papers 1 and 2. Paper 1, those that passed. Paper 2, those that passed, they are 9. They are 9. Those that passed paper 1 and paper 2, they are 9. So therefore, probability event E2 is equal to number of candidates in the event E2 over total students or candidates. That is 9 over 60, and it reduces to 3 over 20. Roman figure 2, part C. We are interested in those who passed paper 2 but failed paper 1. So let E3 be the event that a candidate chosen at random passed paper 2 but failed paper 1. Paper 2 passed, paper 1 failed. You have 16 of them. So there are 16 in that category. So probability, the event E3 is equal to number of candidates in the event E3 over total number of candidates. You have 16 over 60, and that is equal to 4 over 15. Roman figure 3, we are interested in subgroup. Now, not the total candidates. Subgroup of those who failed paper 1. This paper 1, those that fail, this total sample space there is 36. So, sample space for the subgroup of those who failed paper 1, you have 36. So, let E4 be the event that a candidate choosing from the subgroup of those that failed paper 1 but passed paper 2. Failed paper 1, passed paper 2, that is 16. So you have probability event E4 is equal to number of candidates in event E4 over total number of candidates. That is 16 over 36, and it is equal to 4 over 9. Example 41. 3 balls are drawn one after the other with replacement. That means the total is not affected. From a bag containing 5 red, 9 white, and 4 blue identical balls. What is the probability that they are 1 red, 1 white, and 1 blue? Solution: let arrow be equal to red balls. You have 5 of them. W equal to white balls. You have 9 of them. B equal to blue balls. You have 4 of them. Total balls in the bag: 5 plus 9, 14, plus 4, you have 18. Let A be the event of drawing 1 red, 1 white, and 1 blue. Therefore, probability event A is equal to probability 1 red times probability 1 white times probability 1 blue. Since the event is with replacement, total number of balls is not affected. So, probability event A is equal to number of red balls 5 over total 18 times probability that 1 is white, number of white balls 9 over total 18 times number of blue balls 4 over total 18. When you simplify, you have this result, and after multiplication you have 5 over 162. Example 42. A bag contains 12 white balls and 8 black balls. Another bag contains 10 white balls and 15 black balls. If 2 balls are drawn without replacement from each bag, find the probability that A part of the question, all 4 balls are black. B, exactly one of the 4 balls is white. This condition without replacement means the total will be affected and that the events are dependent. Solution: let W equal to white balls, B equal to black balls. From the first bag, W is equal to 12, B is equal to 8, the total is 20. From the second bag, W is equal to 10, B is equal to 15, the total is 25. From the question, 2 balls are drawn from each bag, making it total of 4 that the question required. So let A and B be the events that 2 balls are drawn from the first bag, and S and Y be the events that 2 balls are drawn from the second bag. Let E1 be the event that all 4 balls are black. We are now taking the A part of the question, probability E1. That is equal to probability the first 2 balls are black from the first bag and the remaining 2 balls are black from the second bag. So probability BA, BB, that is the 2 balls, the first 2 balls are black from the first bag, is equal to probability BA, which means the first ball from the first bag is black, times probability BB, which means the second ball from the first bag is black, given that BA, that is the first ball from the first bag, is black. Black balls in the first bag, they are 8 over total of 20 times. You are picking a black ball again, so the total remains 7 over 19. When you simplify, you have 14 over 95. Probability BS, BY, that is the remaining 2 balls are black from the second bag. It is equal to probability BS, which means the first ball from the second bag is black, times probability BY, the second ball from the second bag is black, given that BS, that is first ball from the second bag, is black. You have 15 black balls in the second bag over total of 25. You are drawing a black ball again, you are left with 14 of them over total of 24. When you simplify, you have 7 over 20. Therefore, probability all 4 balls are black is equal to 14 over 95 from the first bag times 7 over 20 the second bag. When you simplify, you have this result, and finally 49 over 950. The part of the question we are interested in, exactly one of the 4 balls is white. Let E2 be that event. Remember, you are drawing 2 balls each from the 2 bags. That will make the total of 4. But out of the 4, 1 is white. So you do that at each stage from the first and second bag. So this is the first two balls from the first bag times the other two balls from the second bag. So from the first bag, if the first ball is white, the second must be black. And in the second bag, the two must be black. Or the second arrangement. If in the first bag, the first one is black, then the second must be white. And in the second bag, remaining two must be black. Or in the first bag, if the two are black, in the second bag, the first one is white, the second must be black. Or in the first bag, the two are black, in the second bag, the first is black and the second is white. We have these possibilities. Let's come back here. The first bag, number of white balls, they are 12 over total of 20 times black ball, they are 8. The total is now 19. You have kept the first white ball that was drawn. We are working with without replacement. The second bag, number of black, they are 15 over total 25. If you are picking black again, you are left with 14 over total of 24. When you come here, you have the first bag. Black ball, they are 8 over 20 times white ball, they are 12 over 19. After keeping the black ball, the total is 19. Notice that all is addition. Second bag, what you have here is the same with this one. So the same values here will be here. We'll come here. In the first bag, black balls, they are 8 over 20. Without replacement, you are left with 7 over 19. This is the second bag. White ball, they are 10 over total 25 times black ball 15 over total 24 after keeping the white ball that was drawn. We'll come here. The same value here will be here. So you have this. When you come here, black ball in the second bag, they are 15 over total 25 times white ball 10 over 24. If you simplify this bracket and this bracket, you have this result. If you simplify this, you have this result. If you simplify this, you have this result. And simplify this, you have this result. When you simplify this bracket, you have this result. Both are the same, so you have the same result. These two brackets are the same. When you simplify them, you have these fractions. The first two fractions are like fractions. So you add the numerators and you have 84 over 475. The last two fractions are also like fractions. If you add the numerators, you have 14 over 190. The LCM of 475 and 190 is 950. Divide 950 by 475. You have 2 times 84. You have 168. If you divide 950 by 190, you have 5 times 14. You have 70. If you add numerators, you have 238 over 950. And that simplifies to 119 over 460. 75. End of lesson 10. Thanks for following to the end. Don't forget, watch out for more from the voice of Petakus. If you are not saved, your life is in trouble, your life is in crisis. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Be good to yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.